everyone. Thank you for listening to my talk about MySQL replication crash safety. My name is Jean-Francois Gagné. I'm a system and MySQL expert, and I work at HubSpot. At HubSpot, our mission is to help organizations grow better. We develop and offer a tool online for that. You can visit our website if you want to know more. So this talk is not recent. The first time I gave this talk was 2 years ago. But the reason for giving this talk today are still very valid. Replication crash safety is a complicated subject. People are confused about it, and it did not get any simpler in the last 2 years. So 2 years ago, there were documentation bugs about this. They were fixed. But today, there are still documentation bugs about this. And I know because I opened 2 just a few days ago. So let's dive in and enjoy my talk about demystifying MySQL replication crash safety. So our agenda for today is quite classic. I will start by giving details about replication, so introducing the subject. I will give details about what we're talking about, like replication safety, unsafety, what it is, what are the problems and the solutions. We'll complexify things a little with GTIDs and multi-threaded slaves. We'll talk about the impact of durability, and I'll define that a little later. And we'll touch on a few other subjects like MariaDB, Pseudo GTIDS, and others. And at the end, I'll do a short summary, closing remarks, and the classic link bugs and everything. So a quick note on terminology. So in this talk, I'm using the legacy master and slave terminology from MySQL. I'm planning to use the new primary, source, and replica terminology when we'll be a little more advanced about defining replacement, especially that this talk will talk about multi-threaded slaves that you can see in this slide, show slave status, log slave update, master and slave info, and also like the one that includes it all, the slave master info table. So it doesn't really make sense to introduce new terminology in the context of this talk. And before diving into the subject, there will be some recurring themes in the talk. So ways to make things safe should also be fast. So things should be safe by default. And we need a better relay log recovery. So you'll understand as I go through the talk, but I wanted to introduce those subjects. So a quick overview of MySQL replication. So you can look on this on the diagram here. From the left, a commit happens on the master. So data goes into InnoDB and then in the binary logs, not necessarily in this order. And the binary logs are the journal from replication. Like this is where the master stores everything that has been modified in the database. On the slave, we have the IO thread that is connecting to the master and is downloading the binary logs. And the IO thread saves those binary logs in the relay log, which act as a local buffer for the slave. This is the buffer of the transactions that needs to be executed. And it's the SQL thread that executes those transactions. So it does run the transaction and then put data in InnoDB, in the local database, the storage engine of the slave. And optionally, if log slave update is enabled, the slave will write itself binary logs to be the master for other slaves. So what is replication crash safety? So after a crash and the recovery of a slave, replication should be able to resume. We shouldn't have any replication breakage, and we shouldn't have like error messages in show slave status like duplicate key or row not found. It's okay if a slave rewinds a little in its state, like as long as it will be able to resume replication and converge back to the state of the master. And now we talked about the slave. What about the master? So the master can also crash. And after recovery of a crashed master, the slaves should be able to resume replicating from it, which is not always the case. So this is also important. And all this without sacrificing data consistency. So we do not want silent data corruption or data drift between slaves and master, because there are some cases where replication will be able to recover, but the data consistency is compromised. We have data drift. And so if this happens, which is quite hard to detect, but if this happens, we consider that like replication here wasn't crash safe. So there's two types of replication crash safety, slave and master, and we'll cover both in the talk. So a quick note about intermediary master. So those are slaves that are also writing binary logs. They're both master and slaves. So when we analyze all this, an intermediate master needs to be both slave replication crash safe and master replication crash safe. So we're not talking about like non-transactional storage engine. Like MyISAM is clearly out of the discussion for this. We're talking about crashes, and MyISAM like doesn't survive crashes. So we're talking about transactional storage engine like InnoDB, TokuDB, and MyRogs. And a quick note before we dive into the subject, it's quite easy to prove that something is not replication crash safe. Like you just need to show that replication breaks or show that you have data corruption. It is harder to prove safety. So take everything that I say with a grain of salt. Like make sure you understand all this. Maybe I'm wrong on some subject. Like I think I'm not, but like I could be wrong on subjects. New bugs could be introduced. We've seen that in the past where it was crash safe before and bugs were introduced. Now it's not crash safe. So like what I'm trying to say here, it's quite complicated, and like don't bet everything on replication crash safety. Like be able to restore things from the backup. So the state of the Dolphin and the Sea Lion about replication crash safety, I will not read all this slide, but at the bottom you can see that everything can be master crash safe, and MySQL 8.0 is master crash safe by default, and I like this. Like things should be safe by default, but none of the others are slave replication crash safe by default. There's always something not completely working. So MySQL 5.5 and MariaDB 5.5 were not crash safe. The others, we can make them crash safe, but we have to be careful. And this is the goal of this talk, to understand all this. So to understand replication crash safety, we have to dive a little more into the details of how replication works. So the state of the IO thread is stored into what is called master info. And the state of the SQL thread is stored in relay log info. I'll have a diagram about this in the next slides. But if we look at show slave status, we can see that the master info here is those two lines. It's a file and a position. So the position is the offset in the binary log that match this file. And the relay log info is both a position in the relay log of that slave and the matching position of in the binary logs of that slave. Yeah, so like this changes a little with GTID, but we'll cover GTID a little later. Like in my own opinion, there's nothing wrong about the file and position. Like everything is good there. It's just that we need something else to do failover, and that's my pet subject, binlog servers. But this is another subject. So now we'll continue about replication details. So in MySQL 5.5, master info and relay log info are stored in files. So in the diagram here, we can see at the bottom on the left master info and on the right relay log info. Those are files. And so when the SQL thread is making progress, is applying a transaction, it commits it in InnoDB and then it writes it to the file, but there's no way to do to make this atomic. So the SQL thread is not able to make progress and track its state in an atomic way. Same thing for the IO thread, appending some transactions in the relay log and writing into master info is not possible to do at the same time. Also, the IO thread will not flush the relay log every time it writes to it. So here I have to introduce writing and flushing. when the IO thread writes something, or when MySQL writes something in general, it writes it to Linux and then it sits in an operating system buffer in memory. And when we flush, we ask the operating system to put this to disk, so to be persistent and to be able to stay on disk after a crash. So if we flush the relay logs every time the IO thread reads a transaction, it's quite slow. So we don't do that. But it means that after a crash, the relay log might not match exactly the state that they were before the crash. So for all those reasons, like MySQL is not replication crash safe in 5.5. Before talking about the solution of 5.6, I want to introduce two more parameters, sync_bin_log and InnoDB flush log at TRX commit. So those impact the durability of InnoDB and the binary logs. So sync_bin_log equals something like 1 for the safest parameter, means that binary logs are flushed every n or 1 transaction. So they're actually made persistent on disk. So binary logs are always written in an operating system buffer, but they're not always flushed. Like if we put sync_bin_log equals 0, like MySQL will write the bin log to Linux, but MySQL will not ask Linux to put those binary logs on disk. So after a crash, we might lose something. So InnoDB flush log at TRX commit, and I will use TRX commit for short in the rest of the talk. When it's equal to 1, InnoDB flush its log every transaction. So it's the safest and it's the default. When it's equal to 0, InnoDB will write and flush its log every second. So it means here that if MySQL is crashing, like not even an operating system crash, MySQL is crashing, there will be data that stays in the memory in MySQL for InnoDB that is not on disk. So this is obviously not crash safe. If TRX commit equal 2, InnoDB will write the log after each transaction. So this will survive a MySQL crash, but it will only be flushed every second. So with an operating system crash, we lose data. So now that all that is defined, let's talk about MySQL 5.6 replication crash safety. So a reminder, 5.5 is not crash safe because there's no way to do things atomically. So we cannot trust relay log info. We cannot trust master info. And we cannot trust the relay log because they're not flushed. So 5.6 solves that by introducing atomicity for tracking the SQL thread state and its actual progress. So there's a new parameter called relay log info repository, which by default is file. So we're storing relay log info in a file by default, like 5.5. But you can set this to table. And this parameter there allows for atomicity for the SQL thread state tracking. So when the SQL thread will commit something in InnoDB, at the same time, it will update its state. So now we have atomicity between relay log info and the data. But there's absolutely no way to get atomicity for the IO thread. The relay logs are files, and it's impossible to append data to a file and update a file, even if it's a table. Like we append data to the relay log, and then we need to commit something into a table. So it's not atomic. So MySQL 5.6 introduced something called relay log recovery, and we'll talk about this just later. Just something here, like there's this X that just happened to sync relay log info. So when relay log info repository is in a table, like this parameter becomes useless and is ignored by MySQL. So relay log recovery is the second part of MySQL 5.6 replication crash safety. And there's something also like master info repository to a table. Like I don't think it's very useful. Like it brings nothing for replication crash safety to put this in a table. I think it's a good thing to put this in a table. Like we don't have like files anymore that are managed by MySQL, but from a replication crash safety point of view, it's not useful. So relay log recovery. So by default, when MySQL starts, it creates a new relay log, and the IO thread starts downloading transaction from the master and write it to this new relay log. So that's the standard behavior, which is the default when relay log recovery equals 0. If relay log recovery equals 1, on startup, MySQL will discard the master info. It will discard the position of the IO thread, and it will set it to something that is trustworthy, like the position of the SQL thread. So let's remember about show slave status. There's a position in the relay log in the SQL thread state. So it takes that and it overwrites the position of the IO thread with this. And it's trustworthy because it's in a table. And then on MySQL startup, relay log recovery sets the position of the SQL thread, like the relay log position in the SQL thread, to the newly created relay log. So the SQL thread will only consume the new relay log that will be downloaded by the IO thread that are trustworthy, because it's from a trusted position. So said otherwise, the previous relay log, which are untrustworthy, are completely skipped. They're discarded. And that's okay for MySQL 5.6 for a first implementation. But there are problems there. Because this will be done on every MySQL startup. Even if MySQL doesn't crash, we wipe the relay log, and we have to re-download them from the slave. So it's something that is not cool in all situations. So MySQL 5.7 didn't change much in that. The relay log recovery is still simplistic, and there's no change in defaults. In MySQL 8, relay log recovery is still simplistic, and I don't like that. There are known problems with a simplistic relay log recovery that are the first 2 bugs below. So a lagging slave after a crash and a restart will have to download a lot of binary logs, and it will overload the slave. And even that on a MySQL startup. So that's not cool, and the fact that it hasn't been improved makes me a little unhappy. We have new defaults in MySQL 8. So relay log info repository is now default to table. This is good because we need this for crash safety. Master info repository is also set to table. I'm not sure if this is useful, but relay log recovery is unchanged. I don't know why Oracle hasn't updated this. Maybe because it causes problem on a simple MySQL restart, but the solution here would not be to be unsafe by default. It would be to have a better relay log recovery. So this is a 2 other bugs below. Implement a better relay log recovery, and please Oracle make MySQL 8 crash safe by default. So now we're done understanding the solution for MySQL 5.6 crash recovery, and we will now introduce more complexity with GTID, crash safety for masters, and multi-threaded slaves. So let's start with GTID. So GTIDs are also introduced in MySQL 5.6. This is a very interesting technology that is very useful. We'll see that in a minute. We'll see how in a minute. But the way it works is that every transactions are tagged with a unique identifier when writing to the binary logs. But that means that the GTID is in the binary logs. So the GTID state of the master and of the slaves are now are tracked in the binary logs. And also, the IO and the SQL thread states are now partially in the binary logs and the relay log. If you're using GTIDs for replication, you need a good GTID position, and this position is in the binary logs. That also means that in 5.6, you need log slave update on slaves to use GTID. So optionally with GTID, you don't have to do that, but I advise you to do this, is you use GTIDs to replicate instead of file and position. So this is the change in the SQL and the IO thread position. Right? This is not a file in a position anymore. Like this is a GTID. So this makes it easier for repointing. Like after a master failure, you're able to repoint things thanks to GTIDs. So that's a good improvement. But this relies on precise tracking of the GTID state of the master and on the slave. And sadly, when you do not sync your binary logs because you need some like performance, you need more performance, so you set sync bin log to 0 as an example. It means that the GTID state of a master or of a slave will be compromised after an operating system crash. So that means that GTID replication is not crash safe with sync bin log not equal to 1. And that's a problem because it means that if you're using GTID and if you want extra speed, like you won't be able to be crash safe. So there's a bug. So bug 70659 for 5.6. It was opened by Facebook that is known to use GTID and that is known to use sync bin log not equal to 1. So Yoshinori Matsunobu opened this bug, and this bug is to this day still not fixed. And also a bug that I found a few days ago is that the manual is not telling you that you need sync bin log equal 1 for GTID replication crash safety. So I opened this bug, I reproduced a crash and a replication breakage. And this is a very recent bug, so that this is what I mean when I say that the documentation is wrong about this subject. So GTID with MySQL 5.6, to be crash safe, you need all those parameters. So relay log info repository to table, we're not surprised here. Relay log recovery, like same thing for file and position. Sync bin log equal 1, and also InnoDB flush log at TRX commit equal 1. When we use sync bin log equal something not to 1, we also usually don't set 1 to TRX commit. But for crash safety, we need those two to be equal to 1. So in 5.7, the default for sync bin log equal 1. So that makes me happy because now MySQL is safe by default. So TRX commit was already equal to 1 for the default of 5.6, but sync bin log default for 5.6 was 0. So I'm happy with the progress Oracle made there. But so in 8.0, we're still missing relay log recovery to 1 to be crash safe. So that was what was making me unhappy before. Like I'm still unhappy about this. So make sure that like if you want replication crash safety with 8.0, change this parameter to make sure that MySQL will restart correctly after a crash. So MySQL 5.7 adds a table. It's the MySQL GTID executed table for tracking the GTID state. So Oracle did that to remove the restriction of having binary logs and log slave update on slaves to be able to use GTID. And that's good because there are situations where you don't need binary logs on the slave. But sadly, this table, is executed is updated at every transaction if you don't have binary logs or log slave update. But Oracle decided to update this table only at binary log rotation when you have log slave update. So I don't know why they did that, maybe for performance reason. Like that doesn't make a lot of sense to me because they're already updating after each transaction the other table that is tracking the file and position for the SQL thread. Like they should be able to update the other table at the same time. It shouldn't be like a big cost. And that really is the missed opportunity for operating system crash safety with sync bin log not equal to 1. So this is a bug I opened only for 5.7. So it's the follow-up of the Facebook bug to like make GTID replication crash safe like with less durable setting. And in this bug, I suggest to update the GTID executed table after each transaction. So when you're running a GTID slave with sync bin log not equal to 1, after an operating system crash, like not just a MySQL crash. A MySQL crash is fine because everything lives in the Linux memory buffer. But after an operating system crash, your binary logs are truncated, you lost the GTID position, so you should restore a backup. However, the file and position of the SQL thread is trustworthy. So we might be able to do something with this. And like this is what I call the voodoo method for saving a GTID slave after an operating system crash when you have low durability. So it's a trick of the invention, but I made it myself. So understand it really well before you use it. It involves not starting automatically replication on that slave. And then it involves like noting the GTID position. Like this is not fully, like this position is not complete. So you have to know that it's partial. And then you wipe the binary logs with reset master to make sure that you don't have anything in your way. You use file and position replication, and then you start replication on the trustworthy file and position. Then you run a few transactions, so you'll start to have a GTID state on that slave. You stop replication, and then you restore the GTID state. And I don't give you more details about how to restore the GTID state. You should only use this method if you fully understand it. And if you understand it, you should be able to know what you need to do for restoring the GTID state. And I blogged a little about this, so you can check my blog. But make sure you don't use this trick unless you really understand it. Like this is voodoo. Yeah, but I think it's useful, so I wanted to share that with you. So MySQL 8 is storing the GTID position in InnoDB. This was done in the context of the clone plugin that needs a reliable GTID position. And like this is something that other people have been doing for some time. Like Facebook has been doing that in MySQL 5.6 for some time in their fork. But it is unclear if this solves the problem about GTID replication not being crash safe with low durability. And this is in InnoDB. This doesn't work for other storage engines like MyRox or TokuDB. And like remember that replication is something that it is built at the MySQL server level. It's not built in the storage engine. And now this GTID position is in InnoDB. It is kind of like if we rely on this for replication, like we're being intrusive in the design of MySQL. So like in my opinion, it would be much better to update the GTID executed table after each transaction. But it looks like MySQL 8.0.17 and next are replication crash safe with low durability. When I did some tests to replicate the bug that I opened, I tried to cause problem, and I was able with 5.7.32, and I was able for 8.0.16, but I was not able to break replication with 8.0.17 and 8.0.22. So it looks like those bugs are fixed, but they're still open on the bug system, so I'm unsure what to think about this. So now let's go into master replication crash safety. We already saw that if we relax the durability of the binary logs, we lose binary logs on the crash. We lose the GTID state on the crash. But what about the impact on the master? So if you're running with sync bin log equal something not equal to 1, you're probably also running with trx commit not equal to 1. And then after an operating system crash, InnoDB and the binary logs will be out of sync. Both of them will have rewinded to the previous flushed position, which might not be exactly the same. InnoDB is flushing every second, and the binary logs are flushing like whatever the operating system wants. This is problematic, and the failure modes will be different in different situations. So I wrote a blog post series about this. I'll go very quickly into what happens. So if a master crashes and didn't sync its binary log, a slave is probably now pointing into binary logs that are gone. So on restart, the master will write a new binary log, and the slave will point into nothing. So the slave is pointing in vanished binary log, and And because the master rewinded its binary log in its InnoDB position, the slave has more data than the master, and two different states might not have the same data. And so slaves are broken. Every node has different data. So it's big data corruption, like not cool. And if some slaves were not yet to the binary log that are vanished, what will happen is those slaves will not break, like replication will not break on those, but they'll skip transactions that other slave will have. So all data is corrupted here. Like this is pretty bad. With GTID, and in this example, I'm using like GTID 50 to 60 that are lost after a crash. So the binary logs matching GTID 50 to 60 are lost after a crash. So the master restarts and only see 49 in its GTID. So it will start creating a transaction in a new binary log with GTID 50, 51, and so on. So like now we have the old 50 to 60 and the new 50 to 60. So because the master will reuse GTIDs after a crash, well, it's not exactly a reuse. Like the binary logs are gone, so the master doesn't know that those GTIDs were allocated. So it will reuse them. But the slave has seen those. So the slave, in this case, has seen 50 to 58. So if the slave reconnects before the master has reused 50 to 58, replication will break. The slave will have more data than the master, and replication will break. But if the master has already reused 50 to 58, and let's say it's at 60 now, so the slave that has the old 50 to 58 will now download the new 59 and 60. But the slave knew the old transaction and the master has new one. So the slave here is skipping new transactions. So this is data corruption again, and this is obviously not good. So when you're running with sync bin log not equal to 1 on a master, the binary logs of the master cannot be trusted after an operating system crash. So you should make sure that no slaves reconnect to such master after a crash. So the way forward here is to fail over to a slave, to promote a slave as your new master. And you can use online mode equal on or off, offline mode equal on to avoid slaves from reconnecting to a master. So if a slave crash with sync bin log not equal to 1, then its binary logs are corrupted. So you should like purge all those binary logs, like running reset master on this slave. But if this slave was using GTID, like you need to use the voodoo trick, or you need to restore from the backup. And remember that intermediate master are both slave and master, so you need to consider both. So here are bugs related to this subject. Like GTID should be crash safe with less durable setting. Make running MySQL with sync bin log not equal to 1 safer, and the missing comment in the documentation. So now we've covered like the simple solution of MySQL replication crash safety in 5.6, GTIDs. We've covered master. Now we're left with parallel replication. So multi-threaded slave, MTS, is a great improvement for replication speed, introduced in 5.6. It's made better in 5.7. But in 5.6, multi-threaded replication is doing out-of-order commit on slaves. And what do I mean by that? So if I have transaction A, B, C, D, E on the master in that order in the binary logs, show slave status might be pointing to B. So it means A is executed on the slave. But C and D might also be already executed because of out-of-order commit. Like they could be in different schema, which is how multi-threaded slave is working in 5.6. So C is being C and E are being committed, B is being executed, and D is pending. So we have a hole on the state of the slave. This is the same thing in 5.7 by default, unless you're using logical clock parallel replication with slave preserve commit order, which is not on by default. And until 8.0.19, you couldn't set slave preserve commit order without log slave update. So that's a good improvement in 8.0.19 that Oracle did to allow slave preserve commit order on a slave without binary logs. But out of order commit as a problem. So it means that the file and position is not enough to track the state of a slave. So GTID allows to track a complex position, but file and position doesn't. So there's something like the slave worker info table, which is very complicated to understand. I'm not presenting it here. You can read the work log if you want to understand how it works. So without GTID, resuming replication after a crash needs filling the gaps. And this didn't work in early versions of 5.6 and 5.7. It was fixed since then. So recovery is doing start slave until SQL after MTS gap. But this needs relay log. And after an operating system crash, the relay logs are gone. So this means that my multi-threaded slave without GTID is not safe for operating system crash and out of order commit. So there's a workaround. You can set sync relog equal 1, but it's a performance killer. It really is not cool. Like you want multi-threaded slave to have faster replication, not slower. The state in the slave worker info could be used to recover. Like there's a way to do it. It would be very complicated to explain, and I don't have time for this. But if it's possible to recover, then it means it's possible. If it's possible to recover manually, it means that it's possible to recover automatically. So relay log recovery should be able to implement this. So we're yet again at needing a better relay log recovery. So what about with GTID? So with GTID, parallel replication is replication crash safe, but you need to enable GTID replication. So you need to set master auto position equal 1. And because GTID, you need sync bin log equal 1 and you need TRX commit equal 1, unless you have binary logs on the slave. So yet again, an example, A, B, C, D, E, transaction number 10, 11, 12, 13, and 14. So the slave that has executed 1 to 10, 12, and 14 before the crash. So after recovery, like everything is good. We don't lose the position because we're syncing on our binary logs. The slave will fetch number 11, 13, 15, and so on. But this needs sync bin log equal 1, which is slow. And if you're using multi-threaded replication, you want things to be fast. So yet again, we loop at the problem of needing a trustworthy GTID position. And remember that the voodoo trick that I gave you before only works with in-order commit. So if you have slave preserve commit order to on with logical parallel replication, you can use the voodoo trick. And if not, like you can't, and like you have a problem. So we need better relay log recovery here. But I said it should be, I said multi-threaded slave should be crash safe, but actually there's a bug about this. So this is a regression. I think it's a regression because I found that there was a problem and that was fixed in 5.7.28 and in 8.0.18. So like if you, unless you run like quite an old version, you shouldn't hit this bug, but this is quite important that you know that there's a bug here, which is a very simple workaround. I think this bug was introduced in like fixing the gaps, and it means that the recovery doesn't work well on version prior to that. And there's an easy fix. Like if you run stop slave, reset slave, start slave, it solves the problem. Like I think you should know this. Okay, we're done with multi-threaded slave. Let's now talk about like some other subjects. So low durability. So sync bin log equal 1 and TRX commit equal 1 are needed for master crash safety. And that was how we made MySQL I available in the past. But modern MySQL I availability doesn't rely on restarting the master. It relies on failing over to a slave. Also, flushing to disk improved in the past. Like magnetic disks were 10 milliseconds. We had RAID cache that were very fast and good SSDs that were also fast, like 0.04 millisecond and 0.15 millisecond to put data persistently on disk. But the cloud came, and in the cloud, putting something reliably on disk is a network round trip. It takes 0.6 millisecond. So in the cloud, running with sync bin log and TRX commit equal 1 is not super fast. So a lot of people in the cloud are running MySQL with sync bin log equals 0 and TRX commit equal 2. So yet again, we go back at needing like GTID and reliability without sync bin log equal 1. And MySQL won't be like 100% cloud ready until these bugs are fixed. Like DBA always need to work around those problems. So we didn't talk much about MariaDB. MariaDB still store master info and relay log info in files. It's disappointing, but it always stores its GTID position in table, and that is good. So it means it's replication crash safe even with low durability. But its relay log recovery is really not good. Like if you want to know more, you can read my blog post about this. But MariaDB has a very interesting feature. Like it has, if you're running with many storage engine like InnoDB and MyRox, it has a GTID table in both storage engines. So you can read more about on the link below. About Pseudo GTID, I'll go very fast on this. Like if you want GTID feature without using MySQL GTIDs, you can use Pseudo GTIDs. And you can get replication crash safety with Pseudo GTID if you're always syncing your binary logs and if you do in order commit. So it's good to know you can use this. So about complexity. So how to start on this? Like all this is quite complex. And even with all the complexity we add in this talk, like I want to point out that there are many tables to store replication information. The replication position is sometimes stored in files, sometimes in tables, sometimes in the binary log, sometimes in InnoDB. And all this is very complex. Like GTIDs are complex, edge cases are complex. Remembering all the content of this talk is complex. I really would like Oracle to build complexity out of all this. Like we need something a little more simpler to be able to operate MySQL. And back to the binary logs, I think they're an interesting break for building a more simple solution. So in conclusion, all this is very complex. It has many edge cases. Things are changing, hopefully for the best, sometimes for the worst when bugs are fixed. And I'm sorry to tell that there's no short version on replication crash safety. On this diagram, every parameter here somehow is either thought to make replication crash safety when this is false, or they needed for replication crash safety, and I even forgot to. There's also slave parallel type and slave preserve commit order that are not on this schema. So I'll try to wrap this up. If you want master replication crash safety, sync bin log equal 1, TRX commit equal 1. That's simple. That's all you need. It's more complicated for slave replication crash safety. So some parameters never impact replication crash safety. So forget about those. Sometimes people think they're useful for replication crash safety. I don't think they are. Some parameters are always needed for application crash safety. Make sure you use them. And there are some special situations. And I think there are only 3 special situations. If you're using GTID with log slave update, then you need sync bin log equal 1 and TRX commit equal 1. If you're using GTID with out of order commit with parallel replication, so in addition to sync bin log equal 1 and TRX commit equal 1, you need master auto position equal 1. And if you're running out of order commit without GTID, then you need sync relay log equal 1, and it will be slow. So this is what I mean by out of order commit. Like you can read the description. You can use the voodoo trick if you're doing in-order commit with GTID and sync bin log equal 0, TRX commit equal 2. And in-order commit will happen in this case. So thank you very much for Daniel Nietzsche, who did a blog post on demystifying MySQL 5.6 replication crash safety. So all the diagrams in this talk are inspired by this post. So thanks, Daniel, for giving me the idea and the structure for those diagrams. All those are blog posts or talks from myself about this subject, so you can read more. We have a lot of bugs on this subject. Some are closed, some are still open. I think it's useful to have those to be able to know the history on this subject and to know a little more. So feel free to read them. And if you find a bug, please open it so it can be fixed. And there are more links on the subject that you can read if you want to know more. So thank you very much for listening to my talk. And I hope you will have a good rest of the conference. Thank you very much.
Hey, Jean Francois. Thanks for registering for MinervaDB Athena 2020. Good to have you here, man.
Oh, it's good to be here. Thanks for having me.
So first of all, let me formally thank you from Team MinervaDB Athena. This means great. I tell you why, because it's the first time we are doing a conference at this scale. We've been doing a lot of meetups. We arrange a lot of meetups at customer premises, MinervaDB office premises worldwide. But this is something new because we are connecting with people even outside, and the speakers are from outside our current ecosystem. So everything new, and the support from you means a lot for me as an organizer, people who are the audience. That's great. Thank you, Jean Francois, for taking time and registering and talking for this event.
Yeah, my pleasure. I think I've learned a lot from conferences that I attended, so I want to give back and contribute to great conferences. So thanks for having me.
Wonderful. Okay. When you submit your talk about how you can build replication infrastructure more responsive. When I say responsive, the term, it's like how you can troubleshoot MySQL replication infrastructure more intuitively. There've been a lot of discussion. So most of these talks have been the committee of the event are customers, our followers in multiple media. So when I shared this, the question was like, hey, when we hear from someone like Jean Francois about troubleshooting MySQL infrastructure, right? What will be the guidance we can hear from Jean Francois, who can help us in understanding MySQL replication from bottom up, where how you can build it for a scale from a mid-size or from a very early stage MySQL replication adopter to someone who is already on MySQL replication on a larger scale. Do you want to share with us your stories? That'll be great.
Yes, so it's a hard question because your question is very wide, from very large internet properties to small startup, and the needs of those people and those companies are completely different. So there's no silver bullet, and it's a classic IT answer. It depends. It depends on a lot of things. But let me try to give two pieces of advices here. So for very large internet properties, you need to have a DBA on staff. So if you don't have one, just get a DBA. And make sure you provide all the help that this DBA needs. Let him attend to conferences, let him stay up to date and get training. And so one of the help you can get is by having a support contract with a MySQL consulting company, or you can hire a consultant that are expert in the specific challenges that you have. So that's for large internet properties. So for startup, like you probably do not have a DBA, and you probably do not have like the right size to hire a DBA. So focus on your business. Don't over engineer your infrastructure, but consider getting external help. Like I think it's a common mistake for startups to delay addressing their MySQL problem, and then when they hire a DBA, it's very challenging for that DBA to fix so many problems that are like now too big. So my advice for startup is start addressing MySQL problems early when they're small and that you don't have too many problems. And like again, consider getting help from MySQL consulting company or consultants. So yeah, I hope
got
it's
you.
answers your question.
Yes. So my second that a second question. The continuity of that conversation from me is like setting up a replication on MySQL infrastructure is quite straight. When I say quite straight, there've been a lot of documentations. I mean, like, hey, how do I set up MySQL master slave, master relay slave, delayed slave, synchronous, asynchronous, semi-synchronous replication? Building up, load balancer on top of it, which could be a HA proxy or proxy SQL or a MaxScale. The complexity get in when you have replication on production, right? Now, like how you can be more responsive, like when you been like a very much more experienced person like you who have set up very large complex MySQL replication. How do you look forward to having maybe top 5 metrics you can't afford to miss, or you continuously keep monitoring, or you're alerted to on building a responsive MySQL replication infrastructure? You have something to share?
So you mentioned a lot of tools, and I'll loop back to that at the end of my question. And you mentioned monitoring. Yes, have good monitoring to be able to monitor replication, monitor MySQL in general. But this is not just the job of the DBA, and this doesn't limit only to the MySQL and the database world. Like good monitoring, like to become observability, it needs to extend to the application, and it needs to be in the scope of developers. So like to organization, like don't rely only on the DBA to have observability. Like this is the role of everybody. And I'll just talk about something I've heard about this. Like an example is the MySQL slow query log. So it's not related to replication, but it's interesting because like I know of a situation where an outage was caused by a slow query, and then DBAs were asked to make the slow query log available to everybody in the nice interface. And like DBAs are not good to develop like web interfaces. So obviously this is useful to have the slow query log in an interface, but it's very noisy. Like the slow query log only like log queries that are above a certain threshold, but some queries, like it's normal that they're slow, it's normal when it's abnormal when they take like a little more time. So this is not like the slow query log is not a silver bullet here. A good solution in that specific situation is to build your observability in the application. And so developers should have a notion of how long a query should take, and they should specify threshold for like reporting warning errors and even aborting the query. So like this is monitoring and observability. Like back at best practices in replication, like avoid classic traps. And I'll mention a few classic traps, but like just to understand this, like I think everybody knows that in security, you do not re-implement your own encryption. Like you don't do that. So do not re-implement replication. Like it's like re-implementing replication like is not a good idea. Also, like another classic trap is naive retry logic. And an example is like always read from the primary, and then when the primary fails, read from replica. Like this is naive retry logic. You will discover replication lag when it's a bad time to discover replication lag, because you always go to the primary, and then when it fails, you go to a replica, and then oops, you haven't thought about replication lag, and then you have replication lag in your face. So don't build naive retry logic like this. Always read from replicas. And another naive retry logic in the context of replication is, if you have a lagging replica, like fall back to another replica for reads. That looks like a good solution, but it will cause like bad things. Like if you have a few lagging replicas and then you overload your other replicas, then those replica will also start to be lagging. And I think you can see the cascading failure scenario here. And what scares me here is that some proxies and solution on their market are providing those features about retries and stop reading from some replicas without giving warnings. It's like, don't do that. Like, stay in the best practice of replication. And as you said, like, MySQL replication is good old boring technology that is well understood, and that works very well. So that's good, but be prepared for surprise. And this is where I loop back to the tools that you mentioned at the beginning. Like, be prepared for replication breakage and make sure that you have a good toolkit to be able to solve problems. And the way you get this is by attending conferences, by reading blog posts, by chatting with other experts. So stay up to date to be prepared when things go badly. And when you have a situation that like you faced, after the dust settles, ask yourself, how could I have solved this in a better way? And if this involves doing a feature request in MySQL, well, please do it. Like, we need more features in MySQL to provide us with easier operations.
Cool. The point what you told is something very close to most of our community discussions, right? If you are looking at MySQL replication, stop considering MySQL replication as a simple high availability solution. Look at beyond that. Look at like how I can scale horizontally reads across several slaves. I tell you, technically, this from an application engineer's point of view, the biggest concern they come forward with is like, look, I have wider range of updates. Like I have like 150,000 records I'm updating, and that's gonna take some time to propagate to the slave. And if I read slave then I'm going to have an inconsistent data to read from there. Now that leads to adoption of load balancers like Proxy SQL or HA Proxy or MaxScale. But putting all these things together, roots to exactly what you said. Most of these load balancers are not raising a flag before they route queries to a slave nearby or farthest actually. So these are something, like someone as experienced as you, who has been on the database infrastructure ecosystem for reliability, for scalability, for high availability, been working so far, right? So long. How do you run a, I don't call it a run book, rather a checklist, right? When I'm building a replication infrastructure, what do you think I should avoid? I should avoid from choosing a replication automation or replication operations architecture or logic. Like as you said, like do not reinvent replication. That's a great point. Like you don't invent a replication model, rather you just follow what works great. So
what you should avoid is just doing something in your corner without listening, without getting feedback from others, and without like having a good understanding of best practices. Attend conferences, read blog posts, and like you mentioned about like big updates, like I have a full talk on this subject, and that talk was how Booking.com deals with replication lag. So go listen to this talk. either me, Eric Ehrman, or Simon Mudd gave that talk, and it's recorded somewhere on the internet. And share your solutions and share your infrastructure, either in a blog post, and you'll get feedback on it. I don't want to tell you not to use a specific technology or not, because there are good reasons to use those technology in some cases. So if I tell you don't use group replication, it might be good for Facebook not to use group replication, but for another company it might be very good to use group replication. It loops back to the beginning, like have people that understand those things with you, get help, and understand your situations, your particular situation, before applying a magic solution that you find on the internet.
I wanted this to be heard from your mouth. I tell you why. Often I get, hey, something, the replication gets more complex when I have larger data sets to manipulate or to update. I personally refer them to your blog post and your video post, which I think was there even in FOSDEM some year back in FOSDEM. Some RootConf, one of the open source database systems conference. I'm not able to. Good that you brought that up, and I want to hear that from you. And I appreciate if you can copy that that link if you could on the Slack. I'm also going to search for that. If I could pull that during a talk, I'm going to copy that on the Slack, because that's a big data for information for people who want to invest and research more on replication for reliability and for scalability. Actually, what in your experience was the most complex replication troubleshooting I've done? Maybe top two, like what really could have destroyed the entire data, the business, and what do you think saved it?
Yes. So I once involved in a situation where, like, a bug in MySQL, and that's an old time, some time ago, ended up corrupting data on a large percentage of replicas. And we needed those replicas for read scaling. So we actually had to let the application read from replicas that were corrupted. So we actually enable idempotent mode on those replica, like keep replicating, ignore all errors, and we started restoring the replicas. That involved a very large amount of replica, think tens of replicas that were corrupted this way. So for reference, this bug is bug number 72610. I'll paste it in the Slack. And so idempotent mode needs to be known here. Another solution would be to use PT slave restart. So those tools are useful to be known. And I mentioned, do feature requests to your database vendor. I think we need a new replication mode here that is not just idempotent, ignoring all errors, and strict, break all errors. We need something in the middle, and I call this the convergent mode. So this mode is only useful in such a situation where you don't want replication to break on row not found or duplicate key, but you'd like to fix your data. So if you get a row not found error on an update, with row-based replication, it would be easy to put the right data in the database. And that's where the convergent mode would be useful. So there's a feature request about this, but it's still not done. So that's an example of a challenging troubleshooting experience. And I'll give you another, this wasn't really challenging, it's straightforward what we have to do. Another one that was way more complex, it's when I deployed MariaDB parallel replication. And I was quite happy with it. I found earlier bugs, but that was in testing. But we got a very good replication speed improvement out of this. But a little later, I found out that some replicas were lagging, and like I thought, okay, what's happening there? And like there were bugs in early versions of MariaDB parallel replication, and I thought it was a deadlock, like a classic deadlock that I saw before. And I reported that to the MariaDB Corporation. Like I had a support contract with MariaDB. And then Valery Kravchuk, that is also speaking at this conference, like he was assigned to this bug, and he made me realize like this is not a deadlock. Like InnoDB is working here, something's happening. And so long story short, like we realized like after testing this with debug builds in production, like Monty even got involved. And so there was a race condition in InnoDB that caused a full table scan on a primary key update. And we found that thanks to parallel replication made that race condition happen once a day. But this race condition was probably happening very like in other situations, and like I think this bug affected other companies, but parallel replication made this bug obvious, and then we were able to reproduce. We found the bug, and the bug was fixed. And like the collaboration here with MariaDB ended up having a bug in MySQL that was solved. So I think this is an interesting collaboration between like MariaDB and Oracle that shows that MariaDB is actually improving the ecosystem, and I'm very happy to have competition here with MariaDB and Oracle to make things better. So like the bug is 82968 that I will paste in the Slack. And like this was about a deadlock in MariaDB parallel replication. There are also still deadlocks in MySQL parallel replication. That's an old bug, number 89247. And very recently, somebody from Percona, I think he's from Percona, did a very good analysis on this bug and pointed out where the problem was. And hopefully this bug will be fixed. So this is another example of like the competing vendor, Percona in this case, in the MySQL ecosystem that is making MySQL better. So yeah, I really like those examples where everybody comes and makes things better.
So well put. You know, like the first one was a tweak where you needed to operate a corrupted replication infrastructure to make sure that business is not impacted. You have the data, you rebuild the fresh replication infrastructure with the data you collected. The second one was like completely collaborative approach where you can't be one-sided. Rather, it means that there is going to be a lot of integration with MariaDB when it comes to the MariaDB specific enhancements to the replication. Again, working core with the InnoDB of Oracle MySQL and you as the end customer who reported this bug. This actually makes one clear line of statement, right? As a database engineer, architect or a database infrastructure owner, you are expected to work in silo most of the times, but that never leads you to that point that you don't integrate your systems with an external core committee or the committer ecosystem. Also very closely work with the support engineer. Like you said, like most of us are who work on MySQL MariaDB definitely knows, have been interacted with Valery Kravchuk and like super passionate about helping people, right? So putting it like that means the community relationship matters a lot. Collaborative engineering is something that's very key. Third one is like, as you started the conversation, like giving back to the community, right? You cannot conceal something which you found it or look out for an alternative solution. Rather, you wanted to make the community, the core committers to be aware that look, MariaDB parallel replication solution can be a solution for that, but look, the inherent MySQL MariaDB replication solution has a bug for this, which which definitely conflicts with my data on our replication infrastructure. Thank you so much, Francois. I doubt anybody else can put this story so so direct, so interesting like what you did today. This also is one direct way that like how deeply passionate you are in educating us. All of us follow your blog. Thank you so much for your effort in sharing your knowledge, speaking in several conferences, so selfless, working all these things in your working hours, and you're finding extra time for us.
And
thank you so much, Jane.
And thank you for organizing this event. Like, you're enabling knowledge sharing, and I'm grateful for that.
Thank you so much, Francois. Great talking to you. Wishing you a Merry Christmas in advance, a great 2021, a good one where we all can move around, meet, travel, and be safe. Thank you so much.